OCI implementation on cloud service models. At IaaS level we can provision and configure all the IT services like VMs. VMs are called as compute instances in OCI terms. Storage is offered as block volumes, object storage, and archive storage. We can also create all the networking services like VCN, subnets, and SGs. In addition, we can also configure governance, auditing, databases, regions, and availability domains. Oracle distributed its cloud services in geographic areas called regions. Regions are separate by other regions and are separate by vast distance across country or continents. Normally applications are deployed to the closed region to itself. Oracle has two types of cloud, commercial and governmental. As of now, only US and UK have governmental regions. Each region has one or more availability domain. Availability domain is one or more data centers within a region. ADs are isolated, do not share same infrastructure. ADs are for disaster recovery. Within AD, hardware infrastructure is grouped into fault domains. A single fault domain shares the physical hardware and power supply. Normally one availability domain may contain 3 fault domains. If you create multiple virtual machine, Oracle Cloud will try to distribute them among multiple fault domains. If a failure occurs in one fault domain, it will not break down the virtual machine. Failure of one fault domain does not affect other fault domain. Cost involved in on-premises data centers. On-premise data centers, its budget is spent on lot of equipment and manpower resources. Any data center should have network infrastructure. Network infrastructure involves routers/net controllers, firewall, load balancers. And there are physical servers. Even if virtual machines are used, they are in fact hosted by physical servers. Depending on how the network is designed, the servers are logically grouped by subnets. But not only servers are assigned to servers, any network-operated machines are also assigned to subnets like printers, scanners, queue machines, cameras, and so on. In addition to that, it is important to have a cooling system. Then we need UPS system to protect the system from outage. UPS provides power for few minutes, but after that we would need power generator to keep it going for hours or days till the outage issue has been resolved. And we also would need monitoring system to monitor and alert for water leakage and unexpected high temperature. We would also need surveillance system, camera are set up throughout the data centers for every possible spot to record and cover every individual who move in and out of data centers. We would also need SOC security services to monitor and analyze organization security needs on an ongoing basis. After accomplishing all those machines, we need people to run and manage them. The organization hire network engineers, system administrators, database administrators, project managers, and etc. to serve those purpose. And to add to that those expense there is software license, it could easily be higher than IT services. The total cost of running DB on-premise data center is high and running them with least possible issue is not easy task. In summary, to have a data center, the supporting systems needed are hardware and machines, maintenance services, software license, related manpower, application. The idea behind cloud computing is, instead of buying the hardware of the IT systems and pay for required supporting systems, let create virtual machines on data centers maintained BT cloud data providers. This way, organization do not worry about hardware or power outages. They can rent virtual machines from cloud providers and configure them as per the application need. With this model, the total cost of ownership is significantly reduced. Cloud services are provided in 3 major models. IaaS, infrastructure as service. PaaS, platform as service. SaaS, software as service. As expected from the name, IaaS provides service related to IT infrastructure like VMs, storage, VLANs, load balancers, gateways, firewalls. When VM is created under this model, it is the client responsibility to maintain the VM and software installed on it like patching, upgrading. The provider provides the VM and OS and rest should be managed by the client. PaaS model provides platform to build application, databases, or develop solutions without the need of installing IDEs or any software. The client uses the platform without worrying about the underlying its structure or OS. SaaS, cloud provides the application like CRM, ERP, HCM. Consumer gets access to the application. Application are configured based on client requirement, the consumer starts using it. This services has largest market share in cloud computing. DBaaS, when databases are offered by cloud, we generally refer to them as DBaaS, IaaS plus PaaS. However, this does not represent a model as such. DB services can be offered as IaaS or PaaS. When DBs are offered as IaaS, consumer creates a VM with DB software installed on it. DB software could installed by consumer or it could be pre-installed by the provider. With this model, consumer has control over the database as the on-premise system. DBAs are responsible for DB creation, pathing, backup recovery, and all those tasks. When DB services are offered as PaaS, consumer just creates the DB as logical abstract. The consumer sets the DB name, its computing power specifications, creates application objects, loads the data to it. Before provisioning DB, it's as important to understand the differences for VM and bare metal in OCI. Comparison between VM and bare metal. Database Virtual Machine, VM, it is a virtual machine with Oracle software pre-installed on it. Because it is a VM, underlying hardware is shared, multi-tenant, between other VMs created within the physical system. A VM comes with single CDB pre-installed, we cannot more CDBs on it. OS and grid cannot be upgraded, we can patch them but not upgrade. We can create 2-node RAC system, but not more than 2 nodes. But customer would need license and requires Enterprise Edition and ASM. VM uses block storage, not object storage. We can configure the storage to allocated storage to be managed by LVM or ASM, LVM, FastPROE, or ASM. In VM we cannot scale up on CPU or memory on fly, but storage can be extended. To scale up CPU, you must change the shape. You can scale up the storage. VM can be shaped from 6 available shapes, which provide the VMs with a number of CPUs starting from 1 up to 24 CPUs. Available shape, 1 to 24 CPU, 15 to 320 gigabytes, max 40 terabytes. Available shapes, VM standard 2.1, 2, 4, 8, 16, 24. OS, Linux. Database bare metal. It is a dedicated hardware, single-tenant, machine dedicated to the customer. We can create as many CDBs as resource allowed. But OS and grid cannot be upgraded, we can patch them but not upgrade. In VM, RAC is not available. Storage comes up with machine itself, it is actually a set of internal local SSD drives dedicated to machine. You can manage the DB storage using LVM or ASM. Fixed storage size. In VM, storage is fixed, but CPU can be scaled. VM comes with 2 shapes, one with 51 terabytes, and the other 28 terabytes. Available shape, 2 to 52 CPU, max 768 gigabytes, HDD, 16 terabytes for 2-way or 9 terabytes for 3-way. Available shapes, VM.Densio 2.52, 51.2 terabytes, VM.Densio 1.36, 28.8 terabytes. OS, Linux. Considerations for deciding the shapes. Storage can be scaled up for VMs but not for VM. CPU cores can be scaled up for VM online but not for VMs. To change the CPU of a VM, reshape the VM, requires downtime. Check service tenancy limits before creating a DB system. As always, estimate the cost. Database editions. Following are the database editions available. Database Standard Edition comes with Oracle Database Standard Edition package plus TDE. Database Enterprise Edition comes with Oracle Database Enterprise Edition package, data masking and subsetting pack, diagnostic and tuning packs, real application testing. Database Enterprise Edition comes with High Performance E+, multi-tenant, partitioning, advanced compression, advanced security, label security, Database Vault, OLAP. Advanced Analytics, Spatial and Graph, Database Lifecycle Management Pack, Cloud Management Package. Database Enterprise Edition comes with extreme performance. Prerequisites to provisioning VM or BMDB system. Virtual Cloud Network, VCN. Do not use a subnet that overlaps with 192.168.16.16/28, used for interconnect. Required ports should be open in the security list and in the system itself. For a 2-node RackDB system, the subnet must have at least 6 available IP addresses. Optional, public/private key pair in OpenSSH format. Tendency resource limits should allow taking the required resources. During provisioning, following database system inputs would be needed. Compartments, system name, AD, shape type, shape, total node count, Oracle Database Edition, CPU core count. Storage management software, ASM, LVM, available storage size, total storage, cluster name, data storage %, data/RECO. Add SSH keys, license type, VCN, client subnet, NSG, hostname prefix, host domain name, disk redundancy, VM normal 2-way, high 3-way. Fault domain, time zone, tags, DB name, DB image, PDB name, administrator credentials, workload type, database backups. Advanced options, character set and national set. SSH keys, we have to provide what type of SSH keys will be used during provisioning. We have 2 options. We generate SSH key pair directly from the DB system webpage, or we upload our own public keys. If we generate SSH keys from the DB system page, we must use generate pair to connect to the system. It's very important to save SSH keys in a safe place. Private key downloaded can use directly connect to DB system from Linux server. If we will be generated private key to connect to DB system from Windows machine, we would need to convert to the PPK format. If we decide to upload our own SSH keys, we need to generate both public and private keys. Provisioning DB system from OCI CLI. You can pass a JSON document containing the input parameter values. To generate a sample JSON document sample. To pass a JSON document to the command. OCDB system launch, options. OCDB system launch generate full command JSON input. OCDB system launch from JSON file :/db-add1-19c.json. In summary, to create a DB system, we need a VCN, a subnet in it, public/private SSH keys, and enough available resources in the tenancy resource limits. OCI console can be easily used to launch a VMDB system. Most of the actions needed to manage the DB system can be performed from the OCI console. OCI CLI commands can be used to manage DB systems and the databases inside them.